Good afternoon, everyone. My name is Victor Wynn, Project Manager.
I'm Gary McQuiston.
My name is Paul Sherman.
My name is Seon Sabita. I'm Ali Kujitor.
For our team, we're called Lumen Networks, primarily because we're working with light technology. So our problem that we had to resolve was the cabling issues within server rooms and other similar environments, in which cabling can be very heavy and can be very costly, as well as a trip hazard. Our system attempts to resolve that by having a light communication system, using LEDs and photodiodes to communicate data. We use LEDs to transmit data, and we use photodiodes as a light sensor to receive data. And how this works is that we are having a system here in which the bridge side and the processor side will be communicating information back and forth. Our objectives for this is to reduce the cluttering of cables, have speed faster than 10 base T, have a distance of about 1 meter just for the scope of this project as of now, and the network should be able to communicate with multiple other networks. So let's say a red network, black network, blue network. And so these overlap networks should communicate effectively with each other. Our setup should be pretty simple. All you have to do is press the reset button. For the performance metrics, we want to measure how efficient our system is. To do that, we want to look at packet loss as a way to see if the packets are dropped, lost, in that sense. Distance is still an issue with us because we want to ensure that there is about a meter of communication being able to transmit data. And we'll also look at error rate, in which percent of packages being able to transmit corrupted versus uncorrupted. Now with this system here, we are in conjunction with Team 1. Team 1 is involved with the network interface connecting our system together to the outside world. We are just mostly concerned with the communication over the free space. To do that, we have our hub, which will be handling a modified version of Token Ring to transmit data to the right relay, and then it will transmit over to the proper node to get to the processor. So that is, in general, how our system is supposed to work. For our transimpedance amplifier, it is used to mainly convert the small current to a usable voltage. And then we'll also have the hub, relay, and node. We're using the Raspberry Pi Zero, the black Vivophone Black X15 to work as the hardware. Are there any questions?
Tell me about your modulation and about your path isolation from your different air paths.
Gary, would you like to answer this question?
So we specifically didn't put very much of that in the slide because our corporate sponsor asked us not to talk about the communication protocol very much because of the NDA.
But it's effective and it isolates the different paths?
As of now, our method of isolating the different paths optically is through light filtering. And yes, light filtering. I wanted to say something.
We will look into more of this as the time
Figured out it.
Yeah.
We are using light filtering, and we're also using an addressing system to ensure it reaches the right node. But beyond that, I don't want to specify anymore.
Do you plan to design this transimpedance amplifier? You have to build this platform. This is given.
I'm sorry, can you repeat that?
The transimpedance amplifier, is it part of your project or is it given to you?
It's part of our project. We had to make that in order to convert the small current for the photodiode to be converted into a usable voltage for that specific part of the system.
What are the considerations when you transimpedance amplifier?
Ali, would you like to answer that?
Well, we need to have it where, in combination with the photodiode, it is sensitive enough, has enough gain to actually get a usable signal across 1 meter. The other thing is that we're trying to get it where it has about 20 megahertz of bandwidth, so that it can handle.
So what is the problem if you want 20 megahertz bandwidth? What's the problem?
I'm sorry, what did you say?
What is the problem if you want to have 20 megahertz bandwidth?
Well, the thing is that for a particular amplifier chip, there's a trade-off between the gain sets of sensitivity and the bandwidth and stuff. We're having to carefully choose the right chip that can give us that performance.
And what about the error rate? How does the transimpedance amplifier relate to the error rate?
The noise of the amplifier can affect that, as well as its sensitivity or its gain, because if you don't have enough gain, then our receiving BeagleBone or Raspberry Pi cannot interpret the signal.
The project is the goal is to remove cabling. So like an IT room, is that an example of where you would implement this, or is this in a larger scale than that, in a server farm somewhere, maybe in Frisco? My question, the reason I'm going with that is if that's the goal, then you need these two to face each other or direct the light to hit each piece of equipment. What's to stop a hand or an object from breaking that light source? And now instead of having one cable disconnected, you've now lost all signals between both devices.
Ideally, our system should be able to work in many applications. So server rooms is correct. That can be one application. Smaller scale systems, that's fine too. We have looked into that as well. We do plan on having a system in which we can have multiple access. So yes, if you had a hand show up, then even if that does happen, data should be able to transfer from one side to the next. And in some sense, they should be facing each other, but they should be able to handle the collisions in the middle.
We were doing this with RS-232 and laser pointers in the 90s. In what way is this different from that?
I don't believe we have looked into that, but we will look into that. What was it called again?
Just serial data over laser pointers.
Serial data. Okay.
A lot of companies that have high-rise buildings will actually have a laser pointer or basically a laser transmitter and receiver to transmit data between buildings. It's line of sight. You need clear airspace, you need ideal conditions for it, but it is done.
Okay.
I will say, with that particular situation, that's point to point, whereas with ours, it's we'll have multiple devices treating the free space as sort of a shared medium.
So maybe, because the application of LiFi sometimes is compared to Wi-Fi, especially in like popular science and stuff, I think maybe understanding what the difference is between what you're doing and what just a regular Wi-Fi type device might be something that would be good to understand, just to be able to explain it.
So you're asking if we're able to differentiate between Wi-Fi and Wi-Fi? Is that?
Sure.
So Wi-Fi is basically data transmission over radio waves. Li-Fi is a term that's slowly picking up. It's where you're transferring data over visible light. So our system is using LEDs and photodiodes to transmit and receive light, respectively.
So in terms of the speed, you say 10 base T. Do you have set parameters for what are you expecting in terms of download speeds and upload speeds?
Yes. Sam, would you like to answer that?
We've just begun testing on this, but we chose to make it more faster than 10 base T because we're replacing that type of Ethernet connection with the light communication. And since we're using light communication, we have aimed it to be faster than 10 base T. But as far as the testing, we haven't gone into the exact download speed.
Right, but is it both ways though?
Yeah,
for
it's
upload and download?
Yeah, it's good.
All right, let's thank the team.